Okay, hi there, Zach. We are going to go over lesson number 67 today. And this one is fun because we are going to review equivalent equations. Okay, and that's when you multiply everything in the whole equation by a number or something like that, and it's an equivalent equation. Okay, and then we're going to talk about a new thing which is called elimination. Elimination makes me think of something else, but I'm not going to digress into that. Let's start with this comic, okay? Here we go. This is another Far Side comic, one of my favorites. Okay. Notice all the computations, theoretical scribblings, and lab equipment, Norm. Yes, curiosity killed these cats. You know the saying? Curiosity killed the cat. Look what the cats are doing. They're like using microscopes, and look what they wrote on the chalkboard. Do you think that's what really happened in here? I don't know. But here we go. I hope you're curious about this lesson anyway. All right, we're going to start out with equivalent equations. So this is a review because you already know this concept. We have already said that equivalent equations are equations that have the same solutions. So let's look at an example. And it's interesting because the first example that they give us in the book, they're like, this is actually not an equivalent equation. So we're going to keep this in mind as we go through this example because this is not an equivalent equation. But they do say that in this situation, the number 2 happens to be a solution to both of these equations. So here's one equation, here's 2 equations, and turns out that if you plug in the number 2 right here, 2 plus 4 is indeed 6, and this is true. And if you plug in the number 2 for x here, you have 2 squared, which is 4 minus 4 is 0, and this is true. So does that mean that these are equivalent equations? No, it does not mean that. And this is the reason why. Because this one right here has another solution. Remember Yoda? These are not equivalent because Yoda says there is another. B has another solution. So let's look back at B. B was this. X squared minus 4 equals 0. We plugged in a 2, but what could the other solution be? Yoda? Yoda says it's a negative 2. That's right. So if you have negative 2, you also get 0, and this is a true equation. So equation A, one of the answers was 2. Equation B, the answer was 2, but also negative 2. So those are not equivalent equations. Okay, so they have to have equivalent, they have to have the same solution set to make them equivalent equations. Here's an example. If every term of an equation is multiplied by the same non-zero quantity, the resulting equation is an equivalent equation. Okay, we learned that rule before. And so it's like if you take this equation, x plus y is 6, and you multiply every single term in the whole equation by 2, you're going to turn this equation into this equation. 2x plus 2y equals 12. And these are equivalent equations because you didn't change the value of any of the variables. Their solution set should be the same. That's how you get an equivalent equation. Easy? Easy peasy. So these are equivalent equations. Did I need to solve them? Actually, yeah, they do solve them in the book because here's what they did. They noticed, and they just gave you the answer. Basically, the ordered pair of 4, 2 is the same for both. So let's make sure it's the same. Let's make sure of that. Let's put it in for this equation on the left. Let's put in 4 for x, 4 plus y is going to be 2, equals 6. You get 6 equals 6, and this is true. Okay, now let's do it for the equation on the right. 2 times x is 4, plus 2 times y is 2, is 12. You have 8 plus 4 is 12. 12 equals 12, and this is also true. And their ordered set is the same. So, okay, so those are equivalent equations. Alrighty, perfect. Now, this is just one of the examples of an ordered pair that is an answer to this. However, turns out there's an infinite number of ordered pairs of x and y that will satisfy either of these equations. But if you choose an ordered pair for the first equation, the same ordered pair is also going to work for the second equation. So they just happen to pick 4 and 2. But you could choose something else. Like you could say, well, what if x is 1 and y is 5? I just did that in my head by looking at this equation. If x is 1 and y is 5, those are going to add up to 6. But if you do choose this for the ordered pair, it's also going to work for that equation because it has to, because they're equivalent. Okay, I think you get it. So I'm going to move on from there. Let's talk about elimination. Elimination? I'm sorry, it just makes me think of bowels. I don't know, maybe it's because I'm a doctor. I don't know what it is. All right, elimination. So far, what we've been doing is we've been using the substitution method to solve systems of linear equations when there's two unknowns. So when you've got an x and you've got a y, what we've been doing is we solve one for x and we substitute it in for y, or vice versa. And that works, and it works great. But we're going to learn a new method, and it's called the elimination method. So instead of doing it that semi-medium, easy, hard way, we're going to try and do it a different way. It's also probably semi-medium, easy, hard, but it's a different way, so we're going to learn it. Okay, this is also, instead of the elimination method, it's also called an addition method. So elimination is the same as an addition method. Let's look at this for a second. These name tags eliminate the need for awkward introductions. And so it's interesting because he wants to eliminate awkward introductions, but he added something, right? He added a name tag. So when you add something, you can eliminate something else. And so that's the concept behind this method. Some wisdom there from SpongeBob, right? Wisdom. All right. We're going to assume x and y represent numbers that will make these true. And that's all. We should always assume that in all of our problems. It's kind of a stupid thing to say, but we're going to assume that x and y are numbers that exist that make these things true. What a silly thing. But you're just saying, assume that the problem we give you actually has an answer. There are some problems that we're going to get into in the future, hopefully way into the future, because it's hard, but that really don't have an answer. But we're going to assume that all of these have answers. Alrighty. Now, x plus 2y is equal to 8. That's equation A. And equation B is 5x minus 2y is equal to 4. Okay, now we're going to use the additive property of equality. And that means when you add something to one side of an equation, you can add it to the other side of the equation, and you're not really changing anything. So what is interesting is that you can add something big, like not just plus 3 to one side, but what if you add 5x minus 2y to the left-hand side of this equation, and then you add 5x2y to the right-hand side of this equation? Can you do that? And turns out, heck yes you can. So that's what we're going to do. So we're going to add 5x minus 2y to this side of the equation, and we're also going to add this to this side of the equation. It doesn't change anything. It's like when we add minus 2y. You can do that, right? Of course you can. We're just adding something a little bigger. We're deciding to add this, and you'll see why we decide to add that, okay? So the other interesting thing is, and I'm just going to tell you this in one step. When you add 5x2y to this side of the equation, you can either add 5x2y to this side of the equation too, or you can just add 4. Why? Because these are equal. So you're adding the same thing to both sides of the equation. Does that make sense? I'm adding 5x2y to this side of the equation, but I'm also adding 5x2y to this side of the equation. I'm just adding the 4 instead because those things are equal. So what that means is what you can basically do is add these whole two equations together. And they're written in a way so that they're on top of each other, and you can just add them top to bottom. And that's why it works. It's because you're adding the same thing to both sides of the equation. So I'm just going to do this, and we're going to add it top to bottom. So we're going to add x plus 5x, and we get 6x. Then we're going to add 2y minus 2y, and that basically cancels out. You've got nothing there. So then you just go equals, and you add 8 plus 4. And 8 plus 4 is 12. So we're going to do this x. And this is what we end up with. 6x is equal to 12. And that means x is equal to 2. Okay. Now, by doing this, we have eliminated the variable of y. That's not in the equation anymore. So that's why it's called the elimination method. You eliminate something by adding the two equations together. And now we can solve the equation 6x equals 12 for x. X is 2, which we did. And now we can take this x equals 2 and plug it in to any of these to get y. So let's plug it into equation A. So equation A was x plus 2y equals 8. So if we plug in the 2, we get 2 plus 2y equals 8. Now let's just solve for y. So we subtract 2. 2y equals 6 and y equals 3. Now just to make sure, let's also plug it into equation B. Equation B was 5x minus 2y equals 4. 5 times 2, which is 10, minus 2y equals 4. 10 minus 2y equals 4. Subtract 10 from both sides. Negative 2y equals 4 minus 10, which is negative 6. Divide by negative 2. Divide by negative 2. Y equals 3, because negative 6 divided by negative 2 is 3. So we got the same thing both times. So that's good. That means we did it correctly. So the ordered pair would be x, which we found the answer to be 2, and y, which is 3. You really only have to plug it into one equation, but just to check your own math, you can plug it into both. All right, let's move on to the next example. High five. We got one done. This dog is giving you a high five. Look how cute he is. Addie would love that. I'm going to put that in one of hers, I think, because it's so freaking cute. Okay, example 67.1 says solve by using the elimination method. Remember, SpongeBob eliminated awkward introductions by adding. So we're going to add these together. That's the elimination method. Okay, so, and the reason that works is because you're adding the same thing to both sides of this equation. You just happen to be adding this to one side, the left side, and this to the right side. But these are equal to each other, and so it works. Okay? And it's written in a way so I can do it top to bottom. Okay? So 2x plus 3x is going to be 5x. Then I'm doing this. 4y minus y. I like to do it the other way because it makes more sense. You could do negative 1y plus 4y, but it's the same as 4 minus 1. So it's going to be plus 3y is equal to 13 plus 3, which is 16. Now, notice something. You still have an x and you still have a y. So what does that mean? It means we accomplished nothing. Cross that off your to-do list. We accomplished nothing. All we did was we got another equivalent equation, but it still has an x and it still has a y. Nothing was eliminated. So that's going to happen sometimes. And what you need to do is you look at the equation and figure out a way to change it so that something gets canceled out. Okay, so when I look at it, I'm looking at these equations. Let's say I want the y to get canceled out. And the y is a good one to pick because one is positive and one is negative, and I don't like to deal with those negatives. So let's try and get rid of the y's. If we get rid of the y's, this would have to be 4y in order for it to cancel out. Negative 4y. That way we have a positive 4y and a negative 4y, and then when we go to add them, one of them is going to get canceled out. So I want this to get canceled out. So the first thing I'm going to do before I eliminate or add is I'm going to multiply this whole equation by 4. And I can do that because it would just make an equivalent equation, and that's fine. It's totally allowable. So let's do that. But we have to multiply every term by 4. So that means start with this. 2x times 4 is 8x. And then we're going to do this. Minus y times 4 is going to be negative 4y. Is equal to, and then we have to do 13 times 4, which, get your calculator out, it's going to be 52. Now the bottom one, I don't need to multiply by anything to get the y's to cancel out because this is already 4y. If I multiplied the top by 4, I get negative 4y, so they're going to cancel out. So it's kind of like you multiplied it by 1, which is fine. It just ends up being exactly the same. So it's a little silly, but let's write it exactly the same. 3x plus 4y is equal to 3. Okay, does that make sense? Alrighty. Now we are going to eliminate. Eliminate the whatever, the 4y's. So we're going to eliminate by adding, okay? So now we're just going to add top to bottom just like before. We have 8x plus 3x right here. So that's going to make 11x. Now we have 4y minus 4y, and yay, they canceled out to nothing. So I don't need to write anything there. And then I write equals 52 plus 53 is going to be 55. And then I can solve that. 11x equals 55. Easy peasy. Divide by 11, divide by 11. Those cancel out. X is equal to 55 divided by 11, which is 5. Okay, sweet. Now I'm getting somewhere. Now I've got the answer, x is equal to 5. But that's only one part of the ordered pair. I still need to figure out what y is. So I've got the 5. Let's put the number 5 into an equation. And you can put it into equation A or equation B. So I wrote them again here. Equation A was 2x minus y equals 13. And it's funny, you could use that original equation, or you could use the one where you multiplied it by 4. It actually doesn't even matter. Because it's an equivalent equation, you should get the same thing. But I'm going to plug it into A. That would make 10 minus y equals 13. And then y is going to be negative 3 because 10 minus a negative 3 is 13 because you're going to have to add 3 to get 10 to 13. Okay, now let's do it in the other one. X is 5, so I'm going to put the 5 in there for this equation. Okay, now I've got 3 times 5, which is 15, plus 4y equals 3. That is, now let's subtract 15. Let's subtract 15. Okay. And then 4y is equal to 3 minus 15, which is negative 12. And then y is going to be equal to negative 3. So I got the same thing both times. which just reinforces that we did it right. You didn't have to do it 2 times. So what is my ordered pair? It's 5, comma, -3. And that is the answer. Okay, perfect. Mission complete on that one. We did it. Woohoo! Let's do another couple examples. I know you are just ready, looking like this, ready to jump right in, get excited. Okay, 67.2. We're going to solve by using the elimination method. So these are the 2 equations. And the first thing I'm going to do is sort of scan across them and figure out what can I eliminate. Now, you will notice this if you're smart, Zach, which you are, is there's probably a million different ways, like infinite number of ways to solve this. I mean, you could multiply equation A by 100, why not? And multiply equation B by, something else. It doesn't matter. You would get an equivalent equation and you would eventually get to the right answer no matter which way you choose to do it. But as you scan across, try and pick a way that sort of makes sense. So for example, what they did in this example in the book is they chose to, instead of getting rid of the y, they're like, let's get rid of that x. Okay, so in order to get rid of the x, we could multiply this whole equation by 3, and then you'd get a 6x here. And this whole equation by 2, and then you'd get a 6, or -2, I guess. And then you'd get a -6x there, and then those would cancel out. Okay, so let's try it. Let's try it. Let's take equation A. Let's see if I did. Nope. So equation A is 2x minus 3y equals 5. I'm going to multiply the whole thing by, let's multiply the whole thing by, I have a different color, -3, because that's what they did in the book, okay? But you could choose something else, and that would be fine. If we multiply every single term by -3, so we're starting with this, 2x times -3 is -6x. Okay, do the next term. -3y times -3 is going to be positive 9y. And then you've got 5 times -3, and that's going to be -15. Okay, perfect. Now let's do equation B. Equation B is 3x plus 4y equals -18. Whoops, -18. Now, I want to multiply this by something so that when I add these together, something cancels out. And now I see this -6. I'm going to try and make this positive 6x so it cancels out. So what do I need to multiply by? I'm going to multiply by times 2. Every single term times 2. So what is 3x times 2? It's going to be 6x, and it's positive. Okay. What is 4y times 2? It's going to be 8y. Basically doubling everything. What is -18 times 2? It's going to be -36. All right. Now I've got these equations right here. And now I'm finally to the point where I can eliminate. All right, time to poop something out. Sorry, that's what I think of with the elimination method. But it's kind of what we're doing, right? We're just going to poop something out. We're going to poop out the 6x and get rid of it. All right, so elimination method, let's get rid of that 6x. So when we add 6x into -6x, we get nothing. So we don't even need to bring anything down here. Let's look at the next one. 9y plus 8y. What does that make? Makes 17y. Okay, now we're going to add -15 plus a -36, and we get -51. Okay, and then we can just solve for y. And turns out, if you plug that into a calculator, y is equal to -3. Now, when I want my ordered pair, I want an x and a y. I already know that the y is -3. Now we just need to solve for the x. Once you've got one of them, then it's easy, because all you do is you take this -3 and you plug it into any one of those, right? Any one of those. So they plugged in -3 for y in the original equation A. So let's do that. So I'm going to get rid of this so I have room. I'm going to write that equation A again. That's before the multiplication, which I think is smart to do because it's just easier. Now I'm going to plug this in for here. 2x minus 3 times -3 equals 5. And it's going to be 2x plus 9. Because it's a -3 times a -3. So plus 9 equals 5. And then we're going to have, we'll subtract 9. I guess I should write it out, sorry. 2x equals 5 minus 9, which is -4. And, divide by 2, divide by 2. X is equal to -2. Okay. So what is my ordered pair? My ordered pair is -2, -3. Easy peasy, elimination method. All right, let's do the next one. Look at this little dinosaur trying to hit the ball with his tiny little arms. He can't do it. Can't be done. Don't even try. Okay, but we're going to try. This is example 67.3. We are going to solve by using the elimination method, but this time eliminate y. All right, well, they want us to poop out the y. So how are we going to poop out the y? I'm kind of looking at the 3 and the 4 and thinking, what's the least common multiple of those? And it looks like it's going to be 12. So I want one to be positive 12y. We should make this one positive 12y. And we should make this one negative 12y. And that way we can eliminate the y. So what do I need to multiply this whole equation by to get negative 12y? I just need to multiply it by 4. Okay, what about this bottom one? What do I need to multiply this whole equation by to get this to be positive 12y? I just need to multiply it by 3, right? By 3. So let's do that. Okay, so I'm going to rewrite equation A, but I'm going to multiply every term by 4. So this times 4 is going to be 2x times 4 is going to be 8x. Negative 3y times 4 is going to be negative 12y is equal to. And then 5 times 4 is going to be 20. Okay, now let's do the next one. I have to multiply this whole equation by 3 in order to be able to poop out the y. All right, so let's try it. We're going to do 3x times 3, and that's going to be 9x. Then we're going to do 4y times 3, and that's going to be 12y. Then we're going to do negative 18 times 3, and what is that? It's going to be 54, negative 54. So that's going to be negative 54. Okay, sweet. Now I've got two equations. They're equivalent equations, and I can eliminate them by adding. So I'm going to add these together. Let me get a different color so it is obvious what I'm doing. Okay, so we're going to take this 8x plus 9x first. So what is that? It's going to be 17x. And then look at this. We pooped something out. 12y minus 12y is nothing. So that's gone. Is going to be equal to negative 54 plus 20. Negative 54 plus 20 is going to be negative 34. So we have 17x equals negative 34. And if we divide by 17, we get x is equal to negative 2. All right, so when I look at my ordered pair, which is x and y, I've got negative 2 in, and I still need to find a y. Find a y. All right. So we can take any of these equations. Let's take the original. Let's see. What do we want to take? Let's take the original A, I guess. 2x minus 3y equals 5. That was the original A equation. So let's plug in this for the x. 2 times negative 2 minus 3y equals 5. So that's negative 4 minus 3y equals 5. Let's add 4 to both sides. Add 4, we get negative 3y equals 9. And then y is equal to negative 3. So my ordered pair is going to be negative 2, negative 3. Easy peasy, that's the answer. We got it. All right, one more example, Zach. Hang in there. One more example. I know, you're trying, I know. But we're almost done here. This is the last example. And you know they get harder, so don't skip this one. Use elimination to solve the system. So these are the two equations. Let's look at them. We've got 2x plus 5y is negative 7, and we've got 3x minus 4y equals 1. So we need to get rid of something. What if, okay, so what they did in the book is they decided to get rid of the y's. And if we multiply this entire top one by 4, then that's going to make this 20y. And then if we multiply the entire bottom one by 5, that's going to make this negative 20y. And then we can poop out the y's. Okay? So let's try that. Let's rewrite equation A, but everything is multiplied by 4. So 2x times 4 is going to be 8x. Okay? 5y times 4 is going to be 20y. Negative 7 times 4 is going to be negative 28. Okay, so we just rewrote equation A, everything multiplied by 4. It's an equivalent equation. Let's do the same with B. I'm going to use a different color. This time we're going to multiply everything by 5. That way we get rid of the y's. So we're going to do 3x times 5. That's going to be 15x. Then we're going to do negative 4y times 5. That's going to be negative 20y is equal to, and then 1 times 5 is going to be equal to 5. All right, now we use the SpongeBob method. We eliminate something by adding. We're going to add these together. All right, 15x plus 8x is going to be 23x. The y's, we just poop those right out. Okay, so then it's equal to negative 28 plus 5. Negative 28 plus 5 is negative 23. Oh, sweet, look. So we divide by 23, divide by 23, and x is negative 1. Okay, but that's only half the problem because that is only part of the ordered pair. But now we know that x is negative 1, and it's easy from here. We just need a y. So let's take the original equation, and the original equation was 2x plus 5y equals negative 7. Let's plug this in for x. 2 times negative 1 plus 5y equals negative 7. So that's negative 2 plus 5y equals negative 7. Let's add 2 to both sides. Add 2. 5y is equal to negative 7 plus 2 is negative 5. Oh, look at that. Y is also equal to negative 1 because you've got negative 5 over 5. Oh, that's kind of cool. So if you're looking at your X and your Y ordered pair, it's -1, -1. It's just the same, it's a dot. Okay, -1, -1. Cool. That was fun. All right, and that is the end of the lesson. And look at Hex Library down here. Hex Library. There's the devil. He's presiding, and this guy obviously did not live a very good life because he's stuck there in Heck. And I didn't even know they had a library in Heck, but apparently they do. And it's full of math books with story problems. Yeah, that sounds about right, huh? You're probably at this point wishing for story problems. You're like, it's probably algebra books. Who knows? All right, hopefully we never find out. All right, love you, Zach. Good job today, and good luck doing your math. Have a great day. Bye.